Good morning, or good afternoon, everyone. It's really good to see such a good crowd. Welcome to the Wednesday afternoon lecture series, or the WALS series. I'm Dr. Catherine Gordon. I'm the clinical director and a senior investigator for the Eunice Kennedy Shriver NICHD. And it's really my pleasure, my honor, delighted to introduce today's WALS speaker, Dr. Jill Maron. Dr. Maron has made remarkable scientific and clinical contributions. She has focused on the area of population health as a neonatologist, with a particular focus on how urban environments can influence health outcomes. Before we begin our program, I want to give a couple of brief housekeeping announcements. First, the code for CME, Continuing Medical Education Credits, is 66835, as you see, 66835, and there's a QR code. Also, for those watching remotely, you'll be able to submit questions to our speaker anytime during the lecture. So you simply click on the button that says Send Live Feedback, which is below in the videocast window. You can type in your message just like a chat, and then we will relay it to our speaker. Just for another housekeeping, we'll give preference initially to those here in the room. There are 2 microphones, and then we'll go to our online questions. And then lastly, there's going to be a short reception to honor Dr. Maron right after this. So for those who are here in person, if you'll just join us as we go up the stairs, it'll give you an opportunity to meet and talk with our speaker. So with no further ado, I'm going to introduce our guest of honor. Dr. Jill Maron is an MD, MPH by training. She is the Chief of Pediatrics at Women and Infants Hospital in Providence, Rhode Island, and she serves as the O. Zaffi Endowed Chair of Pediatrics at the Warren Alpert Medical School of Brown University. This is a role that she's held since 2021. Previously, she served as Vice Chair of Pediatric Research and was the Executive Director of the Mother Infant Research Institute, or MIRI, at Tufts Medical School and Tufts Children's Hospital in Boston. Dr. Maron is nationally and internationally recognized as a clinician scientist. She has broad expertise in newborn medicine, neonatal diagnostics, and translational research. Since completing her fellowship in newborn medicine in 2006, she's built a distinguished career and a reputation as a very gifted clinician, researcher, and mentor. Over the past 15 years, she's emerged as a global leader in the development and integration of salivary and genetic diagnostic platforms to rapidly assess genetic disorders, neonatal morbidities, and potential developmental disorders in newborns. Her research spans neonatal biology, precision diagnostics, maternal infant health, and the application of innovative molecular tools to improve our early detection and outcomes in newborns. In 2016, Dr. Maron became Executive Director of MIRI, and following the appointment of its founder and her longstanding mentor, Dr. Diana Bianchi, when she became Director of NICHD. That was again in 2016. Under Dr. Maron's leadership, MIRI was transformed in a first-in-kind research center addressing all aspects of pregnancy with an expanded focus on maternal health, neonatal research, and placental biology and pathology. During that time, she doubled the number of investigators at MIRI. She grew the Institute's funded research portfolio by over 500%. Very impressive. And through her vision and stewardship, MIRI is now exceptionally well poised to continue advancing discoveries. So the title for lecture today is Neonatal Genomic Sequencing, the Past, the Present, and the Unchartered, Controversial Future. Please join me in welcoming Dr. Maron.
Thank you, Dr. Gordon, for that very kind introduction. This is truly an honor. I do want to thank Dr. Bianchi for nominating me to be here today, and I've just had a wonderful time, and I am truly grateful. I have no relevant financial disclosures that apply to this talk, but I do want to make one disclosure up front, and that is, although I will be talking about genetics, I am not a geneticist. I'm going to be speaking to you today from the front lines of neonatology. of how these technologies are being integrated into the care of our babies, what I'm seeing and what I'm learning. So my objectives today is I'm going to review our recent genomic trials, one of which I was fortunate to oversee for critically ill babies. I will touch upon the work that's going on for our healthy newborns as well. I will identify some limitations to genomic testing in the newborn, particularly as it relates to diagnostic yield and interpretation. And ultimately, at the end, we will weigh the ethical considerations specifically regarding broad and targeted integration of genomic testing in all newborns. So we have seen just an amazing evolution since our first Guthrie cards to diagnose PKU. From one single metabolic disorder with the advancement of tandem mass spec, we now can detect dozens of analytes in a newborn's blood. And of course, then we would further advance our ability to diagnose infants through genetic testing. And this truly, even in the course of my career, has been a genetic revolution. What started were simple karyotypes or FISH analyses quickly in my career moved to what became the bread and butter of our diagnoses, which was the comparative array genomic hybridization arrays. We had SNP platforms and, of course, confirmation always with PCR testing. But it was here where the Human Genome Project was completed, taking 13 years, costing almost $3 billion, completed in 2003, of course, led by the amazing Dr. Francis Collins. And you recently celebrated the 20th anniversary of this remarkable achievement. Well, several years after Dr. Collins and his team had sequenced the first genome, he was quoted in the Wall Street Journal as saying this: "Over the course of the next few decades, the availability of cheap, efficient DNA sequencing technology will lead to a medical landscape in which each baby's genome is sequenced, and that information is used to shape a lifetime of personalized strategies for disease prevention, detection, and treatment." And he was on to something. Not long after he made that announcement, it was Dr. Kingsmore in 2015 who broke the Guinness Book of World Records by not only sequencing but diagnosing a baby in 26 hours. Dr. Kingsmore would break his own record 2 years later, doing the same thing with a diagnosis in 19 and a half hours. By 2022, Stanford would shatter that record. It now was down to 5 hours and 2 minutes, not just to sequence, but to make the call, to make the diagnosis. And then, as many of you probably know, that record was broken again this year. It is now down to less than 4 hours to sequence and diagnose a baby. This is Dr. Monica Wojcik's group out of Boston Children's Hospital in collaboration with Broad and Roche Sequencing Solutions. Every time one of these records are broken, there is much fanfare, and Guinness Book of World Records is present. We use genomic sequencing in my NICU. I will talk a little bit about that, but to give you a price point analysis, commercial rapid whole genome sequencing right now has a $4,000 price point. That is for Trio. That includes mitochondrial genome as well, and you will get that return of results in less than 6 days. That is what is commercially available and in use to us. So where are we? What have the neonatal genomic trials taught us thus far? Importantly, where are we going? Are we going to use this technology in a targeted fashion, or are we going to advocate for broad implementation? And why should we worry about that, particularly when it occurs to our babies? What is the multitude of ethical concerns that we need to really discuss moving forward? Well, when we look at some of the first studies also funded here through NIH, what was known as the EnSight trials, funded both through NICHD and NHGRI, there were 4 studies that were funded asking 4 very distinct questions. One of the first was Baby-Seq, and this was out of the Brigham. And this was asking the question, what would happen if you did sequence both healthy and sick babies? What would our results be? This was different than what Dr. Kingsmore was trying to do with EnSight 1, and he really wanted just acutely ill babies, babies we suspected of a genetic disorder, but we didn't know what it was. The remaining two trials, one out of San Francisco, the other out of Chapel Hill. San Francisco was sequencing the newborn blood spot DNA to see if they could improve and expand newborn screening. And then Chapel Hill was doing the exome sequencing to see the difference in the value that was able to have. And, broad strokes about what it is we learned was that it turns out parents were much more willing to agree to these trials if they had a sick baby. In these early days, if you went to them in their normal nursery and said, we'd like to sequence your baby, maybe we'll find something wrong, they really weren't that interested in that. They wanted to take their healthy baby home. When there were qualitative studies done looking at the psychological impact of families who participated, it really did not appear to have any sustained psychological impact regardless of diagnosis long term. Whole genome would prove superior. It still does to this day, and it really was viewed that it should be the first tiered approach. And there were some issues raised with whole exome sequencing, particularly as it compared to newborn screening mass spec, with a decreased sensitivity and specificity for whole exome compared to our newborn screening technology. And of the limited cost analyses that were done in several studies, it was estimated that we could change management and reduce inpatient costs anywhere from $800,000 to $3 million if we implemented this technology early in life. But what about targeted panels? These are panels that are only looking for genes associated with a certain phenotype. For example, a seizure panel or an epilepsy panel. Or the child has a neuromuscular disorder, but you don't know which one. So you're really just looking very specifically in the genome at a very unique phenotype. And this could have obvious benefits, not just in terms of cost, but maybe potentially not the ethical burdens that a more broad-based test would bring. And the question was, is this a better approach? And this was a study I was involved in. This question hadn't been answered, and this was Gemini. This was the genomic medicine for ill neonates and infants, and it was done, Dr. Jonathan Davis at Tufts Medical Center, pictured here. He and I were MPIs on this study that was conducted across this country. It was meant to be a 5-year multi-state U.S. study. I will tell you it's the first clinical trial, and I have done several, that completed enrollment well ahead of schedule. Parents were very eager to participate in this trial, particularly if they had a sick baby. We sequenced successfully 400 hospitalized infants, trios, meaning their mom and dad as well, if available, of infants who were less than 1 year of age who were hospitalized and suspected of a genetic disorder. We provided rapid whole genome and also a commercially available targeted neonatal gene panel known as Newborn GX. This is owned by Quest Diagnostics, and I'll tell you a little bit more about that momentarily. We looked at time to diagnosis, diagnostic rate between platforms, the clinical utility of these platforms, and the economic value. And the centers you see pictured on your right are the centers that participated in the trial. This was a non-randomized study. Everyone got everything. We always tried to do trios if they were available. So we would collect blood and samples from the parents, and some of that would be shipped off to Genomic Medicine Institute, led by Dr. Stephen Kingsmore, a co-PI on our study, and his lab would perform the whole genome sequencing. The remaining samples were sent to Quest Diagnostics, where Newborn DX would be performed. Now, Newborn DX is a targeted exomic sequencing panel. It has genes associated with disorders that present within the first few years of life, and there are 1,722 variants that are interrogated associated with those gene disorders. It was designed to provide rapid, cost-effective diagnoses without the burden of uncovering things we didn't want to see. In order to be enrolled, pretty much any caregiver could identify you. We deliberately went broad here. So a neonatologist could identify you because they just thought something was wrong, a geneticist or an intensivist if the child were mature enough to be in the PICU. So you had to be less than 1. We had to suspect you had an undiagnosed genetic disorder. If you were critically ill, we could alert the labs that we wanted an urgent read. We wanted a turnaround time of less than 72 hours of arrival of the specimen into the lab. You were excluded if you were less than 23 weeks gestation, had a congenital infection, or you had a genetic diagnosis that fully explained your phenotype. And here as a non-geneticist, I learned something very important. Babies can be born with more than one genetic disorder. And in fact, we would see it. And one of our most famous babies that was enrolled was a baby we knew had Down syndrome, but was dying of liver failure and had inherited a secondary disease, which would ultimately be fatal to him. We met with ethicists before we started the trial, who guided us on how to approach some of the major ethical issues associated with it. The first was that parents had to opt in to receive the secondary findings that are approved by the ACMG for their infant and themselves. This was all in or not in. We did not piecemeal this, okay? But it wasn't opt-in. I will say that is not what is on commercially available platforms such as GeneDx. GeneDx is an opt-out. They will automatically run that unless you educate the parents and they choose to opt out. Our ethicists advise us that if we saw non-paternity, we were not to reveal it. We would, however, reveal incest, especially if we ever saw it in a minor. I am happy to, and report to authorities, I am happy to say that never occurred. And obviously, we were going to have to upload all the data here, where it sits in the NIH repositories. What we learned very quickly was that we were detecting novel variants at a very quick pace. This was one of these studies that we had never started to sequence babies before. And when you did that, you started to see these novel variants. So in the midst of this trial, we had to make a decision. So many of us will not interrupt a clinical trial for interim results as it's ongoing. But because of these novel variants, we felt it was imperative to get them into the literature because that is one of the key defining factors that can elevate a VUS up to likely pathogenic or pathogenic. So we published in JAMA Pediatrics when we were about 28% through of the study. We noticed at that time early on that results were concordant only between platforms 73% of the time. I will say most of this is technical due to newborn DX. Newborn DX cannot find certain things. Certainly if the gene isn't on the panel, they're not going to detect it. But they also cannot detect duplications or deletions that an array could detect. So we were early on seeing this discrepancy. And by 28% population enrollment in, we had already identified 51 novel variants. And we concluded at that time that as comprehensive genetic testing became more routine, these data were going to highlight the critical importance of variant detection capabilities of existing genome sequence technologies and the significant limitations in terms of discrepant platforms that must be better understood. Ultimately, we would complete enrollment. We had screened 466 infants. They were excluded for the reasons listed there. We ended up consenting 407 infants, 6 withdrew, and 400 were ultimately enrolled. 293 would undergo rapid testing, 107 were urgent testing, and almost all families would opt in for secondary findings. The paternal difference is simply because we didn't have as many fathers identified. And here are our results. 51% of enrolled subjects received a variant classification related to phenotype. And I want you to pay attention to that 51% because I'm going to come back to it. Of those, 53% were pathogenic, 19 were likely pathogenic, and 25% were variant of unknown significance. Now, we went back and forth with JAMA on this. We included that in our diagnostic rate because the geneticists and the labs looking at those variants were really confident they were causative. But they were limited by the guidelines that exist that it was novel and we weren't able to call it. There were also 2 variants that were unclassified. 13% of these subjects had more than one variant identified that could be causative, and 1 had 6 separate variants. In total, our study identified 132 new variants that had not been seen before, and 6% of all enrolled subjects who opted in had an incidental finding identified. Our time to diagnosis, Newborn DX, was faster if standardized. If this was just our routine rapid, it took 4.2 days to get the diagnosis with Newborn DX and 6.1 days for whole genome. I will say, by state laws, we were mandated for confirmation. So when I say 6.1 days, it wasn't just that the sequencing identified it. This had reflexed either to Sanger or RT-PCR for confirmation of that variant, okay? And that was particularly true at the time in New York State. That was a mandate. Newborn DX did the same thing. So this is diagnosis with confirmation in that time frame. It flipped when it was urgent. Whole genome was able to turn that around in 3.3 and Newborn DX 4.0 days. And I would caution, it was all hands on deck. These labs were working round the clock. And I know that because I was the call every time a diagnosis came. And I was called at all hours of the day and night when they finally hit it. So they were working 24 hours to get it. But even now, commercially, as I said, these labs are turning it around in less than 6 days for our diagnosis. We saw that Newborn DX failed to identify 112 variants detected on whole genome. Most, again, were technical. 45 weren't even on the panel. If it's not on the panel, you're not going to see it. 58 were structural. Again, those deletions and duplications, regions of homozygosity, the panel is incapable of detecting it. And there were 9 additional due to technical limitations, including mitochondrial, which whole genome would look at. Conversely, whole genome missed 9 that Newborn DX caught. And you would say, well, how could that be? And that's a good question. And the reason for that is when you ask the labs, they said to us, we saw it, and we didn't think it was causative. And here was another thing I learned as a non-geneticist. Your diagnosis is going to vary depending on the lab that you sent it to. They're not all the same based on their algorithms, based on what's bringing up to the geneticist's review and what's weeding out. So not all labs are the same. 9 infants had a suspicious VUS identified in non-coding regions. In other words, it would have been missed by whole exome. And this, in part, is the reason why most of us have flipped now to whole genome. It's because of these, because we're seeing these. We just do whole genome. The other thing that was striking about this study was that we had no idea what it was we did not know. And I'm going to highlight Kabuki syndrome here. Kabuki syndrome, it's listed here. I'm sure many of you are familiar with it. But at the start of Gemini, it was estimated to occur in 1 in 32,000 babies to 1 in 86,000 live births, or 0.003 to 0.001%. In Gemini alone, we had a 1.5% hit rate. And what was crazy was I would get the call. And I'd get called, you have a Kabuki syndrome. And I said, that's interesting. And then I'd get another call, you have a Kabuki syndrome, and you have a Kabuki syndrome, and you have a Kabuki syndrome. What this taught us is that until we started doing these sequencing tests, we didn't actually understand the neonatal presentation of these gene disorders. We hadn't seen it. We were diagnosing these kids at 3, 4, 5, 6. We didn't know what they looked like in the newborn period. And our group and others have now gone on to publish about how common Kabuki syndrome really is and that we had been missing it in early life. When we finished this study and published it in 2024, we were very quickly validated about our hit rate. And this is coming out of Israel. This was published in JAMA Network Open. Israel conducted a similar study. They looked they did the study in 18 medical genetic institutes, 25 NICUs. They enrolled 130 trios, 54% male. Their average time to diagnosis was 7 days. And guess what their hit rate was in these ill babies? It was 50%. So Gemini was validated quickly. You can see here the disease-causing variants. 11% had suspected causative VUSs, and there was only 1 novel gene candidate. I don't know if that's because we had just published on over 100, and so theirs was only 1. There was 9% of the time there was something you could do about what you were seeing, and they concluded diagnostically that this is a very beneficial test in the public healthcare setting. following this study, of course, is another study funded by NIH, and this is Seek First out of Seattle. So Seek First has 3 arms to it, and the investigators hypothesize that most infants and children who could benefit from whole genome are actually not being offered testing, and that testing is highly dependent on geography, institution, and social class. And the 3 arms of this NIH-funded study are targeting 3 different populations. The first, Seek First DDI, is looking at children less than 3 with atypical development. The results, to my knowledge, of this study have not been published. Seek First, All Kids Included, is trying to provide access to sequencing in underserved communities. And then Seek First Neo. And that was to develop and test approaches for equitable access in critically ill infants. And that is what was published recently and what I will talk about now. So what Seek First did in their approach was they flipped the model on us. I told you what it took to be included in Gemini. The authors of Seek First and those running it said, if you're in the NICU, you have a genetic disorder. There's something wrong with you. That's why you're there. And so they have only an exclusion criteria. So they said, we're going to offer you sequencing across the board unless you are already over 6 months of age. I can fully explain what I'm seeing with you based on your based on whether you've had an infection. I know why you were born premature. Mom had bad preeclampsia. I know why you're here, or some type of birth trauma, or pre-existing prenatal or postnatal testing. So this was a sort of a paradigm shift for us, that every baby in the NICU was probably have some genetic disorder. So of 408 infants admitted to NICU, 240 were eligible. Here's what we saw. 126 received whole genome. There it is again, 49.2% got a diagnosis. It's 50%, and it's holding pretty steady. 45.9%, to their credit, were non-white. 114 infants received standard of care, 9.7 received diagnosis, 20.7 received non-white, and those who got the, obviously, standard of care. They did acknowledge that neonatologists were significantly less likely to make a diagnosis in non-white infants compared to non-Hispanic white infants, and standard of care approaches were estimated to miss 42% of infants. So out of the gate, genomic sequencing seemed to be very helpful here as well. So what's the value? This is our economic evaluation. It is published this month in JPEDS. And what we did was we used a decision analytic model to compare one-year health care costs for 2 inpatient testing scenarios. So again, we used our existing data in this model. And we said, okay, well, what happens if you do rapid whole genome out of the gate, less than 7 days of admission, versus you first went to newborn DX, and then, because you didn't get a diagnosis, had to go on to whole genome. So early newborn DX then followed at greater than 8 days after admission, who didn't get it, a diagnosis. This is a perspective of the U.S. healthcare system, and we actually collected data on all of these babies up to 1 year of age, including their medical bills. And what we found was if you got early genome testing, you either got a diagnosis or no diagnosis. Again, early newborn DX, you either got a diagnosis, you were done, or no diagnosis, and you had to reflex to whole genome and either get a diagnosis or not. And when we actually look at this, if you went to early newborn DX, it cost the healthcare system almost $160,000 more than if you had just gone, if you had just out of the gate done whole genome. So this actually guides my own care at Women and Infants Hospital. We offer whole genome sequencing out of the gate in critically ill babies suspected of a genetic disorder. That is our line of choice. That is where we go, and we do it because it makes economic sense. This saves the healthcare system if you do this. But it does beg the question, who's paying for it? And this is where we are, okay? So Project Baby Bear, if you're not familiar, this was led by Stephen Kingsmore Group out in California, and that was to get Medicaid to pay for this in-house, and they were successful. And what I'm showing you is a map. Either we had no coverage, Medicaid only, Blue Cross Blue Shield, or both, okay? Baby Bear because I have to tell you, neonatologists have a problem, and they have to just call themselves something very similar. Florida went down to Project Manatee. Michigan went up to Project Baby Dare. And many of us are at our State House fighting to get this covered because it makes a difference in terms of diagnosis. It can redirect care in a meaningful way for these families and give them an answer without a diagnostic odyssey. And what our group this month is showing, as well as others, is it's actually cost saving. $4,000 out of the gate is nothing, okay? It's nothing, especially when you're dealing with ICU bills and a diagnostic odyssey. So here we are. It's an amazing time. We have amazing capabilities. We could identify child onset disorders, single gene disorders, untreatable disease, adult onset disorders, et cetera, et cetera. But it does beg the question, are we about to open a huge can of worms? Because this is a really, really powerful test. So all the good it can do, it can also identify incest, false paternity, incidental findings and family disorders we're not ready to deal with. We can have infiltration of these genomic databases. We could potentially lose insurance coverage. Now, most of our population is covered by GINA, but we don't know if that will last. Our military are not protected by GINA. So what does that mean? Well, we've begun to extrapolate beyond indication. Up until recently, most, though not all, I did show you BabySeq, of these sequencing trials that were being conducted in newborns were based on phenotypically driven symptoms. We thought you had a genetic disorder. But a new era is emerging by which all infants may soon undergo some form of genomic sequencing, regardless of medical indication. And this, of course, is population-based genetic sequencing. And it's based on the concept that what's good for one must be good for all. And there are all these rare diseases out there. Why wait years until you find it? What if you just started to look? So when we look at population-based genomic sequencing, one of the driving forces for doing it are the existing limitations that we have. We know that majority, even now, of genomic data are derived from people of European descent, and we need that data to interpret the genome. But we're interpreting everyone's genome largely based on what we know about white people. It's only estimated non-white participants in genomic sequencing are about 12% Black, 3% Asian, 3% Hispanic. Trials like Seek First are going to help with that when we broaden our enrollment, when we provide access. But still to this day, this is a problem. And this is written in the press, that the lack of diversity in genomic sequencing research hinders precision medicine for the non-white Americans. So we have begun to do some integrating of targeting sequencing into healthy newborns. And I just want to make a distinction here. This is not whole genome sequencing. This is using sequencing technology for a panel, okay? So this study came out of China. It was 29,601 infants. They were born really at term, normal weight. And it was to broaden newborn screening with a targeted gene panel for sequencing of 128 conditions. The biochemical and genetic tests could be detected for 43 of the conditions, with the remaining 85 were screened solely on that gene panel. And what they found was that of all of those infants, 813 were identified as positive, and 402 infants had subsequently been diagnosed with a positive predictive value of 50.4. And what that translates to is 1 out of every 500 newborns, or 2%, benefited from this gene panel. If you don't know, newborn screening diagnoses a little less than 1%. So this doubles it. If you add a panel on, you might be able to double your diagnostic rate in otherwise healthy children by doing this test. And then, of course, is the NIH-funded Guardian trial, led by Dr. Wendy Chung at Boston Children's. This, too, it is not whole genome, but it is using sequencing technology in a targeted manner for a panel. And Dr. Chung was very selective about the conditions that would be on that panel. She is, in addition to newborn screening, sequencing 156 early onset genetic conditions where interventions could be available. And she also has the option to also screen for 99 neurodevelopmental disorders associated with seizures. Again, targeted genome sequencing to enhance newborn screening. And she, too, published her interim a little over a year ago. She approached 5,000 families with a 72% consent rate. Here is her distribution of ethnicities of those enrolled, almost equally split between Hispanic and non-Hispanic. And she improved that diagnostic rate of newborn screening, which sits at about 1% to 3.7%. And indeed, she did diagnose rare disorders. She did. But I will tell you, the majority of what's driving that 3.7% is G6PD. And not all states will screen for G6PD right now. So this is spreading like wildfire a little bit. When we look globally, who's performing whole genome at birth? UK, Qatar, 14 European countries, China, and Australia. The Economist picked up on this not too long ago, and they said, you know, the one to watch is England, is the UK. And there, and many of you probably know this, they are sequencing healthy babies. Their target ranges from 100 to 200,000. They are trying to identify rare diseases. We'll see where it goes. So it begs the question, are we out of control with this? Is this going way too fast for our babies? So I did give you some disclosures. I'm going to give you another one. I'm not an ethicist. But for the last half of my talk, I'm going to speak from a very deeply personal space. And I'm going to ask a favor of you. I'm going to ask you not to think of me as a physician scientist. I need you to think of me as just Jill, with her dogs and her husband hanging out at home. You see, we've been here before. We have been at a crossroad where a novel technique emerges to address a long-standing hurdle in medicine. It has the potential to do great good and positively impact children and families. It will involve interrogation or manipulation of an infant's genome, but we're only going to be brave enough to think about the short-term good, not the potential for long-term harm. So one of the first neonatal genetic experiments began over 60 years ago. And at that time, I don't know who's aware, but there was this clandestine medical practice whereby doctors would inseminate heterosexual infertile couples with the sperm of medical students, or, on occasion, their own sperm. The physicians identified the ideal candidates for donation, not the parents. The physicians believed that this practice benefited the couple, provided them with a family, and the child, because they selected a great gene pool for that child. They would write about this in books, and I'm quoting from them. Their goal was to select sperm donors who were devoid of hereditary taints, with the mental capacity to advance to upper classes in schools of medicine, and that it isn't absurd to presume that a child of artificial insemination has an advantage eugenically, mentally, and physically. There was great secrecy around that until recently, when several documentaries and autobiographies came to light. I don't know if you know about Dana Shapiro's best-selling autobiography, Inheritance. HBO got right on this as well. Baby God. Some criminals take life, he gave it. And then Netflix, Our Father. Is it yours? Well, the adage is true. Truth is always stranger than fiction. And while I was running Gemini, I had been on 23andMe and Ancestry.com for years, and I never once unlocked my relatives. But there was one day where a series of events would lead me to do so. And when I did, I saw all my half-siblings. I was 46 years old, and neither my parents nor the physicians who made my life possible ever believed I had any right in knowing my truth. This was the big debate back then. I'm that old. Nature versus nurture. What mattered more? And we actually did some horrible things in medicine to get to the bottom of that. right? We know about them. We separated twins at birth. We separated the famous triplets. Well, who were we protecting way back then? Well, my parents got their family. They didn't have to tell me, and they never did. I learned about it online. Then, of course, there's the biological, anonymous biological parent. I will cut to the chase with you. I was conceived in a Harvard Medical School associated clinic with the use of medical student sperm. It was the famous Dairy and Rock Clinic, led by John Rock, who invented the pill. On one half of his clinic, he stopped women from getting pregnant. On the other half, he allowed them to do so with the use of medical student sperm. My biological father isn't just a doctor. He is, in fact, a pediatrician. He doesn't want anything to do with me, and he was afforded every single solitary right to say that to me. But one could argue nature won. I never came from a medical family, heard my whole life, where did you come from? Only to learn this truth at the age of 46. There were, of course, the physicians. They did their job, wiped their hands of me, and never thought of me again. I was something to make and never to protect. And then there was me. I grew up to be that doctor, right? My whole life, I was allowed to tell an erroneous medical history. I will never know how many siblings I have. They just keep appearing. And I have no idea who it is I have passed on to my children. It did not have to be this way. These were choices that were made before I was even born, to deliberately withhold my truth, to allow me willingly as physicians to carry an erroneous and falsified medical record. That's a choice. My colleagues, and I know some of them are here in REI, you're refusing to regulate gamete donation in this country, leaving it up to us. I can't tell you the psychological damage you are doing when you do that. It is not okay to have dozens and dozens of siblings. It is not okay. It is time you protect us. These choices were perpetrated throughout my adult life without my knowledge and never with my consent. This was done to me with zero protections in place for me. So what does this have to do with whole genome? Let's go back and review what it is we've done. I'm going to sequence that newborn without their consent. I'm going to argue or convince myself it is absolutely in their best interest to do so, even if that baby's healthy. I will interpret their sequence, but only disclose to them what we have determined they should know, including truth about paternity. I will confess to you today, there has never been a moment in my life where I felt like such a cliche than that moment. I was devastated. I didn't get it until it happened to me. I listened to those ethicists. I was wrong, and I was trapped because my IRB wouldn't allow me to break it anymore. We had 6 non-paternity, and I had to stay silent, and I am now complicit in a false medical history, and I regret it deeply. I provided no clear path forward for these children. I have no idea that they'll ever know they've been sequenced. I don't know if they can access their sequence, and I can never counsel them throughout their life. But then I uploaded them. I uploaded them into databases, de-identified. So it begs the question, what could possibly go wrong? So here are the questions we really need to consider. What information are we going to actually report to these children if we do this? How do we handle both clinically significant or incidental findings? We haven't talked about this, but DNA is a big deal. All those biological relatives, do they want to know they carry a disorder or a gene mutation? Now, how do we handle non-paternity is easy. Seek First does this. You only sequence the proband. That's going to solve that problem. You're going to lose some of your diagnostic accuracy, but it will solve this problem. What about the psychological impact of the test? How do we address knowledge about adult onset diseases? And how does testing impact the healthcare system? Again, who's managing this? Who's storing it? How are we bringing it back up for reanalysis? How are we linking it to the EMR? And ultimately, how do we protect the privacy of a newborn? Because the greatest oxymoron is not jumbo shrimp. It is de-identified DNA. Okay, it is our identified. The criminal doesn't leave a note at the scene and say, this was me, right? I don't care what you think you did by stripping a name off DNA. It is your identity. It is not de-identified. So it begs the question, is this really secure? Now, many of you may not know this, but we have a real crisis right now with newborn screening. And the infant's privacy is actually at risk. So in December 2020, reporters had uncovered that investigators in California were seeking access to those newborn screening samples, those blood spots. They were doing it to identify criminals. They knew that at least 5 search warrants and 4 court orders were identified to obtain blood spots even before the Golden State Killer. And since then, at least 1 cold case has been solved with the help of newborn blood spots, and police have made at least 1 arrest stemming from the use of these resources. So what I'm saying to you is law enforcement is able to infiltrate our newborn screening program. And the famous case really was the 2021 case out of New Jersey, where police sought access to a blood sample from New Jersey Department of Health belonging to a child who had screened 9 years earlier as a newborn. They wanted to perform DNA analysis to try to connect the child's father to a rape that had been committed 25 years earlier. This is going to go all the way up to the New Jersey Supreme Court, and what the Supreme Court said is, we're going to make it really hard. We're going to make this difficult. You're going to have to tell us in writing why you are justified for going into newborn screening. Obtainment of those blood spots from the state's newborn screening could occur if you get a subpoena, if you have a search warrant based on probable cause, or an administrative subpoena or appropriate court process issued in a missing person or unidentified body case. So what's the summary? Law enforcement can still get to all our newborn screening. Now, Natalie Ram, out of the Texas Law Review, wants to tackle this, and she did. And if you haven't read this paper, it is worth a read. What Natalie did was she went to every state by state, and said, do you protect newborn screening? And you can see almost no one does, including my state of Rhode Island, which is in white. There are 0 laws in place to protect newborn screening. What makes it even more concerning is because we are such a small state, we hold on to those cards for 22 years, which means in the state of Rhode Island, there is a DNA database sitting there, and law enforcement can walk in and get it at any time. Natalie really raises the red flag here. You know, she reminds us that these are public health programs, and law enforcement interests must not be permitted to undermine public trust in these programs or to dissuade new parents from participating in them. And I can tell you, I recently got off clinical service in the NICU, and for the first time in my 25-year career, I have parents refusing newborn screening. They were refusing it. We have to preserve the public trust here. And to conform with foundational principle of respect for persons, law enforcement should clearly and unequivocally be barred from access. Those are her words, and she calls to action. We must do this because every newborn American is counting on it. It will come as no surprise that the ACLU has taken this a step further. When it comes to genomic sequencing, they do not mix words. This should not be done on a wide-based setting. We have got to limit this. They are worried about profiling of our brown and black children. I would say they are right, particularly without the proper protections in place. ACLU is mandating that all states act quickly to amend their newborn screening programs and clarify that legal protections safeguard against both the sample itself and data associated. So I want to circle back to Dr. Francis Collins' quote, and I want to ask the question, should it really be a new age yet? Are we actually ready for this? Or should we pause? Look, I share my story, not because it's easy. There's nothing easy actually about it. But I am well aware that I have a voice. I could be perhaps the only one who's been both part of a genetic experiment and have run trials in genetics. And I am well aware that this is too great a moment with too much at stake to make the same mistakes again. I want to remind you that I don't think all those years ago people thought something bad would happen. They thought they were doing something good. I stand here before you saying great harm was done. I was never going to be the same person. So even with our best intentions, we have enormous capability to cause harm. There's been a lot written ethically about this, and I've written some of it. And I've done my best to read most of it. And I have to tell you, there was never a quote that I've come across yet that has spoken to me more than what was written by Rachel Horton and Anike Lucasen in 2022, when they remind us that babies are a captive audience. They will be entirely dependent on the choices that their parents and society make for them, though they will have to live with the consequences. We have two roles here right now. This is an amazing test. I have seen what it can do. It can and it will save lives. And I want to be clear here. I do advocate it for use when medically indicated. But I also have to be a gatekeeper, because I have seen what this test can do. I've lived it. I've lived the power of a DNA test, manipulation, whatever you want to call it. This is big. And we need to protect those children without a voice now and in the future. And I was fortunate about a year ago to partner with Sharon Terry, pictured here. She is president and CEO of Genetic Alliance, and we were asked to write a commentary for ClinChem. Now, Sharon has two children with a rare genetic disorder, and she devoted her life to trying to change the model by which sequencing was done, so that once you sequence it, it is owned by the individual. It goes back to that person and can be linked into the EMR. And what I really want us to get away from, and I am a neonatologist, and I understand parents are my baby's voices. I understand it completely. But I don't forget that what we are doing is not to the parent, it is to the child, okay? And while parents' voices are important, I want us to stop talking about, well, the parents said it was okay. Well, the parents consented. Well, the parents think, all right? I want us to flip that dialogue and start talking about, but what about the child? The child first. And to me, what this means is that neonatal sequencing data cannot be uploaded into databases for medical purposes until there are clear laws prohibiting access by law enforcement to them. Information regarding sequencing results, or that it has occurred, must be placed in the neonate's charts and follow them throughout their lifespan. Access to genetic and health information contained in the genome must be offered to that individual either at the age of assent or at 18, and then we must be able to offer them genetic or psychological counseling throughout their lifespan. Until we can do this, I would argue we have no business certainly doing broad-based genomic sequencing for our children. And we've gotten really good at doing this technically fast, and this is really remarkable. And I don't want to take anything away from that, but we have failed in parallel to do the hard work. We failed to do this. And if we don't do this, we're not protecting our children. Rather, we sit at this crossroad where we have an opportunity to do great good, but we can do great harm. We must appreciate this enormous responsibility that comes with genomic sequencing. So in conclusion, we are seeing it. I've seen it every day. Genomic sequencing is going to have a significant impact on neonatal care. I truly believe it will save lives. It's going to shorten the diagnostic odyssey, lead to the discovery of new therapies, and improve our understanding of the natural presentation of genetic disorders. But we got to get uncomfortable here and have the really, really hard conversations. We have to acknowledge, discuss, and address the ethical burdens that this is. And most importantly, we can't be so impressed with us because the world record showed up, that we have lost sight of what we can do can never supplant the realization of what it is we have actually done. I am very well aware that I may lose my battle. I sit with colleagues that are so excited about this, they want it to go. But I try every day to use my voice in a positive manner to bring awareness to all the things that are at stake here right now. We cannot have a generation of children grow up and resent us, rightfully so, or be at risk because we failed to inform. We have to do the work in parallel. And with that, I need to thank NIH. They have been extraordinarily kind to me throughout my career. National Center for Advancing Translational Science, who funded this work, and then everyone who participated, most notably the families and those babies who gave their DNA without ever knowing it. And with that, thank you. I will take questions.
Please, we welcome questions on. I have one actually to kick us off. It will be my own. It's not from online. Can you compare the European landscape legally, and how is this influenced by their, I don't know the right words, but universal health care that must influence?
Yeah, it's a great question. I've been following the UK just because I'm curious about what's going to happen with the UK. I don't know how it will impact, first of all, like an insurance perspective once a diagnosis is made. I don't know. I will say they've been very forthcoming with how thoughtful they were about genomic sequencing, how many panels they had about the ethics associated with it. But I don't know about, I imagine their government is funding this, so they're paying for all of it as well. But I do think that to my knowledge, I don't know if police and law enforcement have access to it to the same way they have here in our country. I actually don't know.
Hi. One advantage to sequencing healthy babies is that you can identify compensatory mutations for what would normally be fatal or really serious things. Have you seen a lot of that?
No, I mean, the two big trials that I showed you, the one out of the China, and I think everyone's watching The Guardian when it finally comes out, although it's not whole genome, right? It's a panel. I haven't seen that. I think most of the people really running with just sequencing everyone, it's going to be Europe and some of the Australian and Qatar country, to watch there. So I haven't seen it yet.
Thank you.
Sure.
You must have thought about one step before, as in people using CRISPR to alter at the embryo level or, before implantation, right? That's, there was an article in the New York Times,
yes,
like in the last few days, right? And I'm just wondering, this is, as you say, this is a battle we're going to lose, right?
I know.
And none of this ever addresses the fact that genes have pleiotropic effects in general, right? Mm-hmm. So you do these single edits, you think it's a single edit, and it'll have long-term consequences, possibly, that nobody knows about, right?
Right.
So what are your thoughts about this?
I mean, I think you raise really, really important points. And I think it just comes back to what I was saying is we live in such an amazing technical time, and these are true scientific achievements. But we are not really playing this forward in an appropriate way. I mean, to your point, you're doing this to a baby. You don't even know. These are humans, right? I mean, you're doing this to, you don't even know what's going to happen. These are really, really highly ethical concerns. And then, of course, there have been concerns, the New York Times picked up on this too, like just sequence the fetus and decide, there are concerns that you're just going to decide if you like certain genes that baby may have inherited and what's going to happen. I mean, are we actually going to get there? I don't know. But Times and other reporters are bringing that to light, that the capabilities are here that you could actually fetus sequence, early on in gestation and decide if this was, a pregnancy that was phenotypically what you wanted. These are really big decisions. And the purpose of my talking to you about my personal story is I want you to get uncomfortable. We have to get uncomfortable and confront this. We really do.
No questions online. Do you have any closing remarks, Dr. Gordon?
Yeah, really incredible talk, Jill. And I wonder, was it difficult to recruit? And did you, for your Gemini study, and did you see certain trends among certain parts of the population, certain communities?
Yeah, that's great. It wasn't difficult. We were able to very quickly recruit. I think it's because they were so sick. But I will say it is minority populations who are the only ones I've really seen refuse these testings. And I don't think we've nearly done enough to earn their trust. They're right.
There's room for improvement.
Mm-hmm.
All right. I'm looking behind me. I'm going to stand up. I just want to thank everyone for coming today. Jill, thank you for a fantastic talk, a lot of food for thought, and also for the important work you're doing. And to everyone online, too, thank you for joining us. Those in the room, please join us for the reception afterward.